Hi, everyone. In this video, I'm going to give a demonstration of linear regression using SPSS, where we have sequentially coded our categorical independent variable. So before I get started, I do want to mention that underneath the video description, you'll find a link to the SPSS data file that you see on your screen and that I'll be working with throughout this demonstration. So you can download a copy of the data to follow along. Now, the data set is essentially fictional data, and let's just say that we've collected this data from a sample of students, and in this data set we have an indicator of their education level. So, and then so this would be our independent variable. Our dependent variable would be this measure of deep processing. So one way that we could carry out our analysis with education level, and by the way, it's coded 1 for freshman, 2 for sophomore, 3 for junior, and 4 for senior. So one way that we could carry out our analysis to compare students at different education levels in terms of their level of deep processing is to carry out a one-way analysis of variance. Another possible approach, though, that we could use is to recode the education variable into a set of indicator variables and then include those indicator variables in a linear regression as predictors of deep processing. And so both approaches would essentially yield the same overall effect of education level on deep processing. So a fairly common way of so in terms of the use of indicator codes, that's a fairly common way of including a categorical predictor in a linear regression. But sequential coding is another possibility that one might consider, particularly in those cases where you have an independent variable that is ordered categorical, like the one that we have in our data set. So let's kind of draw a comparison between the use of indicator coded variables and sequentially coded variables. So I created this set of tables right here to sort of draw the distinction between the two forms of coding. So with indicator coding, you can see that in the first column here, I'm just kind of representing education level. And you can see that the levels on this variable include freshmen, sophomores, juniors, and seniors, where freshmen are coded 1, sophomores are coded 2, juniors are coded 3, and seniors are coded 4. And the same would be obviously the case down below in terms of the sequential coding. That's our original variable as well with those original codings. But for indicator coding, you can see that what we would do is we would create 3 new variables for inclusion in our regression analysis. So I'm just going to call them IND1, IND2, and IND3. And so those variables are going to carry all of the grouping information associated with our original variable. So just keep in mind that if you're when you are recoding your variable for a regression analysis, the number of recoded variables that you're including as predictors in the model will equal the number of groups for your original variable minus 1. So that's why we have 3 indicator variables being represented right here. So in the first column for the first indicator variable, you can see that we have a 0, 1, 0, and 0. And then for the second variable, we have 0, 0, 1, 0. And then for the third, we have 0, 0, 0, and 1. So that might not mean a whole lot to you right now, but the basic idea behind the coding is that we can establish uniquely from these 3 variables group membership. And so for freshmen, notice that freshmen are coded 0, 0, and 0 across the 3 variables. So that uniquely identifies freshmen. Then for sophomores, you see that we have 1, 0, and 0. So that would uniquely identify individuals who are sophomore if those individuals have those codes across those 3 variables. Juniors are uniquely identifiable with 0, 1, and 0. And then seniors are uniquely identifiable as 0, 0, and 1. Okay, so you can see that all four groups are represented across the three indicator variables. Now, because the freshmen are coded 0 across those three indicator variables, that essentially makes this group a reference or a baseline category. I'll just say REF right there for reference. And so when you are running your regression analysis, the regression slopes, let's say B1, B2, and B3 right here, these are representing differences in means on the dependent variable between a given group and the freshmen are the reference or baseline category. So you can see right here that for indicator 1, because we have this 1 right here for sophomores, the first regression slope right here is a comparison between freshmen and sophomores. Then for the second indicator variable, because you have the 1 right here for associated with juniors, and you have the zeros on the other variables, then this the regression slope B2 will represent the difference in means between freshmen and juniors. Then for B3, because we have a 1 right here for the third variable, this regression slope will represent the difference in means between freshmen and seniors. So in all of our analysis, in all of the comparisons that are being made or contrasts that are being made, freshmen are being compared against the other categories. And this might be of substantive interest in oftentimes when you're running analyses, you might have, like in this case right here, we obviously have an ordered categorical variable, but in some situations, like let's say you have an experimental study and you're comparing a control group versus different treatment groups, that might be something of interest to you, just comparing different treatment groups against that single control group. But in our case, with education level, it's an ordered categorical variable, and there might be other questions that we have. For instance, we might be interested in addressing the question, well, are there differences in means between adjacent levels on the dependent variable? And so in order to address that particular question, we would need a different coding system. And so that coding system would be sequential coding. We might also call it adjacent or repeated categories. And I will say that this is discussed really nicely in Darlington and Hayes' book, Regression Analysis in Linear Models. That's from 2017. So I'll give a shout out to that text. But in terms of how we carry out the coding, it's a little bit different, not too much though. So first off, we have, I'm just kind of naming our little dummy variables here, SC1, SC2, and SC3. And that's just for sequential coding. That's just my arbitrary naming. So you'll notice that in all cases, we have freshmen, again, coded 0 across all three of our variables. And by the way, just to kind of mention up here with indicator coding, we could have just as easily set any other group as a reference or baseline category by assigning zeros across the IND1, IND2, IND3 variables. So there was nothing special about freshmen other than I just kind of chose to have that group serving as the reference category. Now, so getting back to our sequential coding, we're going to treat our freshmen as group 1 in our analysis. Now, let's say that I want to compare freshmen versus sophomores first, and then I want to compare sophomores versus juniors second, and then I want to compare juniors versus seniors. So to accomplish that, we kind of change up the coding a little bit on our three variables. So you can see right here on the first variable, we've got 0 for freshmen, 1 for sophomores, 1 for juniors, and 1 for seniors. So then for the second variable, we have 0, 0, and then 1, 1. And then for the third variable, we've got 0, 0, 1. So again, just to reiterate, for the first comparison, we are comparing freshmen versus sophomores. For the second one, and by the way, that would be the first regression slope during our analysis. Then we've got sophomores versus juniors, that will be the second regression slope. And then we've got juniors versus seniors, that would be the third regression slope right there. And as you're looking at this, in terms of thinking about how to set this up, just kind of pay attention to the structure here. You can see that it's kind of organized in the following way. You can see that there's kind of a triangle, if you will, that of ones right here, and then you can see that there's sort of an upper triangle right here of zeros. So if it helps, that you could kind of think about how we've structured it in that kind of way. So let's go ahead and open up SPSS. We'll begin just by doing a quick indicator coding, or recoding our ed level variable into indicator variables, and then we'll also use the sequential coding. So to carry out our first recoding of education level into those indicator variables, we'll go to transform, create dummy variables, and let me kind of reset this, and we'll move ed level over to the create dummy variables for box, and where it says root names, I'll just call it IND. Keep it consistent with what we were talking about before, the names that we were using before. So we'll click on OK. And now when we look at our spreadsheet, you can see that we've got IND1, IND2, IND3, and IND4. Now, keep in mind that basically we're only going to be using these three dummy variables right here, or indicator variables, in our regression analysis. So essentially we've got, for this IND1 right here, it's essentially taking group 1, assigning a 1 for that, and zeros on all the others, all the other for all the other groups. For IND2, we're using a value of 0 for the first group, freshmen, then 1 for sophomores, and 0 and 0 for juniors and seniors respectively. Then so basically these three variables that you see right here are consistent with the three indicator variables that I was just showing you a second ago. And so just to kind of clean things up and make it a little bit less confusing, I'm going to get rid of that variable right there. And so to run our analysis, if we're using just the indicator coded variables, we would just go to Analyze, Regression, click on Linear, and we'll move our three variables over. You'll notice that I had on the education level variable included labels, and so you can see that they're kind of named sophomore, junior, and senior. But so if we include those variables and then deep processing right here, when we run our analysis, you'll see right here, you can see the standard R-square value, which and then the f-test, and these results right here are just basically reflecting the overall effect of our grouping variable on the dependent variable. And if we actually ran a one-way analysis of variance, the eta squared would be equivalent to the R square, and the f-test would be equivalent to what we have right here. If we look at the regression coefficients that are provided in the table below, you'll see that for the intercept, this is actually the mean for deep processing for freshmen. So the intercept for our model is because the intercept is equal to the predicted value on y, our dependent variable, when all of the predictors are equal to 0. Remember that for the indicator variable, we coded it 0 across our indicator variables. So that would be the mean for freshmen. And then the slope right here that is associated with this indicator variable right here, this is not referring to sophomores specifically, but the slope is the difference in means between sophomores and freshmen. And if you add the intercept and the slope right there, that would get you the mean for sophomores. Then you can see that we've got this value right here, the 6. That's the difference between freshmen and juniors. And so if you take the intercept and you add the slope right here, that would get you the mean for juniors. And then finally, we have the difference between freshmen and seniors. And if you add this value right here, the 8 to the 20, that would get you the mean for seniors. And just to kind of validate that intuition for us, we'll just kind of quickly run our analysis. I'll just do a quick one-way ANOVA. We'll move education level right there. We'll move deep processing here. We'll go to options and we'll select descriptives, and we'll just kind of keep it simple in terms of our output and click on OK. And you can see that what I was kind of talking about. First off, notice that there's our eta squared value, the 0.614, which was equal to the r squared value that we saw before. The f value and the p value that's given right here, these are the same values from the regression analysis. The 48.843 is showing up in the ANOVA table here. And then in terms of the regression coefficients, as I said before, here's our intercept, which is 20, and that's associated with the freshman. This is from the ANOVA output down below. Then for sophomores, take the 20 and add the difference between the two groups, which is 4 right here. So that would give you the 24 for sophomores. That's the mean for sophomores. For juniors, it's going to be 26, which you can see right here. And then for seniors, there's the regression slope of 8, add that to the 20, and that gets you the 28 that you see right there. So we've essentially just run the one-way analysis of variance using linear regression with the indicator variables. And then the tests associated with the regression slopes are essentially contrasts. And we were testing differences in means between each subsequent level and the reference category. So in terms of this difference right here between freshmen and sophomores, you can see that difference was significant. Between juniors and freshmen, you can see that was significant. And then between seniors and freshmen, that difference was statistically significant. So now let's go back and recode using sequential coding. So what we'll do is we'll go to transform, we'll click on recode into different variables, and we'll take our ed level variable, our original variable, this one right here, and move it over to the numeric variable box. And we'll start out just by calling our first variable SC1. And click on change right here, and then click on old and new values. Now remember what we were talking about before in terms of how our variables are recoded. So in this particular case, just keep in mind that if we go back to that earlier slide, think about it. We had ed level, and so we had freshman, sophomore, junior, and senior. And then we had SC1, SC2, and SC3. And so for SC1, we had freshmen coded 0 across. And then for sophomores, we had a value of 1 right here on the first variable, and then 1 and 1 for the juniors and seniors. Then for SC2, we had 0, 0, and then 1, 1, and then for SC3 we had 0, 0, and 1. So we want to keep that coding system in mind as we utilize the recode option in SPSS. So what we'll do is where it says old value on the education level variable, we had a value of 1. We're going to recode that into 0. So, and keep in mind, right now we're just focusing on the first of those variables that we're constructing. So we'll click on add, then level 2, which is sophomore, we're going to assign a value of 1. Click on add, then junior, which is a value of 3, will be given a 1. And then senior, which is a value of 4, that will also be given a 1. So we'll click on add and then continue. And then when we click on OK, we're going to get that new variable appearing right here. So freshmen will be coded 0. The individuals in the other categories will be coded 1. So now we'll go back, we'll do another recode, and we'll just go ahead and name this one SC2, click on change, and then click on old and new values. Now, in this particular case, remember that we were going to have a code of 0 for freshmen, a code of 0 for sophomores, and then 1s for juniors and seniors. So really the only one that we have to worry about then is this recode right here. So previously on the other variable, we had assigned a value of 2 on the original variable, a value of 1 on the new dummy variable, if you will. In this case, we're going to change this to 0. Okay, and we'll click on change right there. So now you can see that a value of 1 on, so freshmen are coded 0, sophomores are coded 0, juniors and seniors are both coded 1. We'll click continue and then on OK. And then the next one, we're going to go ahead and go back to recode again. We'll highlight this, and I'm going to go ahead and give it a name of SC3 right here and click on change. We'll go back to old and new values. And in this particular case, remember that the only group that was going to be assigned a value of 1 is seniors. So for the juniors, which are coded 3, we're just going to change this coding to 0 and click on change right there, so that now just the seniors are given a value of 1. So freshmen, sophomores, and juniors all are being recoded into 0 on this last variable. So we'll click on continue and then on OK. And now we have all of our sequentially coded variables for our analysis. So we'll click on analyze, regression, and linear. We'll go ahead and move these guys out and move our sequentially coded variables in and click on OK. And so now you can see, as we're looking at our output, notice again, there's the R-square value, the same R-square that we had before. There's the F-test. All of that is exactly the same as before. So the overall effect of the independent variables on the dependent variable, it's exactly the same. But now instead, as we're looking at the regression coefficients, the intercept is still the mean of our freshman group. And you can see also that the regression slope associated with that first dummy variable is still a 4, because we're comparing freshmen versus sophomores. Okay, so that actually is going to be the same as what we had before, and you can see that difference in means is statistically significant. So then, if you look at the second regression slope, now you see that we have a value of 2, and this represents the difference in means between individuals who were sophomores and those who are seniors. So in that particular case, you can see that the difference in means is statistically significant at p.022. And then you can see that we have for the last regression coefficient, this is a comparison or contrast between juniors and seniors. And so in this case right here, you can see that this value is statistically significant. So just keep in mind too that the values right here that are positive, just think about it as for this first slope right here, this would be equivalent to taking the mean for sophomores and subtracting the mean for juniors. And so that's essentially the mean of sophomores was 24. The mean for the mean for sophomores is 24. The mean for freshmen is 20. So obviously, if you take the former, subtract the latter, that's what gets you the 4 for that regression slope. The regression slope that you have right here, this is the difference in means between juniors and sophomores. And so basically, if you just kind of take the 20 and then add the 4 and the 2, that gets you 26. Subtract 24, from that, that's what gets you the 2 for that regression slope right there. And then you can see that this last regression slope, basically the mean for seniors is going to be 28, and if you subtract the 26, then that gets you the difference of 2. So just to show you an alternative way of running that analysis and kind of demonstrating what we were talking about, we could run another one-way analysis of variance. I'm going to go ahead and use the general linear model, go through univariate right here, and you can see I've kind of specified everything. And I'm going to go under contrast, and we're going to set this for repeated. So we've got this set for repeated contrast. Click on continue, and I'm really just going to also just kind of go ahead and request the marginal means as well. Click on continue, and then click on OK. So you can see really quickly, dependent variable, independent variable. Actually, we're going to get rid of that variable right there and just kind of focus on those two. So when we click on OK, and you can see first off in terms of our f-test and eta squared, once again, the eta squared is 0.614. That's equivalent to our r-square value. There's the test of the effect of education level on deep processing. That's all the same right there. If we kind of scroll down a little bit further, you can see the differences in mean. So you can see using the repeated contrast right here, we have level 1 versus level 2. That's level 1 is freshmen, level 2 is sophomores. And so the way this is laid out, you can see that we've got the difference in means. It says -4 right here. In the regression output, it was +4. The reason why is because in this specification, it's actually the mean for freshmen minus the mean for sophomores. And so basically the mean for freshmen, that was 20. The mean for sophomores was 24. So 20 minus 24, that's the -4 that you see right there. Whereas in the regression output, the regression slope is actually the mean for sophomores minus the mean for freshmen. And so in that particular case, that's what's got you the +4 that you see right there. But the significance test results is, it's all exactly the same. Then you can see we've got level 2 versus level 3. So the contrast estimate, the difference right here is between sophomores and juniors. So, this is sophomores versus juniors right here. So just recall again, this is basically the mean for sophomores minus the mean for juniors. And so that's what gets you the -2 right there. In the context of the regression analysis, it's the slope is equivalent to the mean for juniors minus the mean for sophomores, and that's why that value was 2 in the regression output. So it's the same difference. It's just kind of reoriented a bit. But the result, there's your p-value of 0.022, and it's exactly the same as what we saw in the regression output. Then we've got junior versus senior right here. So you can see another -2. And so, and you can see that there's our p-value of 0.007. So it's exactly the same as what we had before. Once again, the -2 that you see right here, this is just due to, we're taking the mean for juniors and subtracting the mean for seniors. The mean for juniors, by the way, was 26. For seniors, it was 28. Take the difference, and that's the -2 that you have right there. In our regression output, it was the mean for seniors minus the mean for juniors, and that's what produced the +2 that we had for the regression coefficient. But as you can see, this offers, kind of a different way of analysis and just simply relying on the more conventional use of indicator coding. And it allows you to kind of make comparisons between ordered categories on your so that's associated with your independent variable that you would not necessarily be able to do without a lot of subsequent kind of recoding it into various indicator variables. So this is a lot easier than, obviously, than just kind of going back through and using the indicator coding and kind of changing up your baseline or your reference category. So that's pretty much all there is to it in terms of recoding your categorical variable into sequentially coded variables for the purpose of regression analysis. Obviously, too, you can go back and you can include other predictor variables in your analysis if you want to, but just kind of keep in mind when it comes to interpretation of your regression output, just be mindful that you are incorporating controls at that point. But this is just kind of a general overview of how you could use the sequential coding during your regression analysis. So that's going to wrap up this video demonstration, and I appreciate you watching.